In this case, we're going to use another strategy that's different from Elena's and different from Noah's, and this is called an area diagram or an area model. So you can use area diagrams to represent products of decimals, and this one shows 2 and 4/10 times 1 and 3/10. So what it's done, we can see in this picture, is it's taken 2 and 4/10 and split it up so that it's 2 and 4/10. And they've drawn a rectangle, and the reason it's called an area model is we're going to use this space as though we're finding the area of each of these 4 rectangles and then add them all together. So I really suggest drawing this in your notebook, and I already have. And we're going to take each of these rectangles one at a time. The first one that I'll start with is, well, let's first understand a little bit more of what they did here. So they took 2 and 4/10 and split it up by place value. So our ones and our tenths are separated. So there's my ones and there's my tenths for the first number. There's my ones and my tenths for the second number. So that's how they split it up. They went by place value. They're going to multiply all of the ones together and all of the tenths together, and then that one times this tenth and this one times that tenth. So that can be a lot to hold in our head, which is why an area model is a helpful thing to have. So the first one that I'm going to do is 1 times 2, right? If I'm finding the area of just this rectangle, right, base times height, 1 times 2 makes 2. And then I can move on to this rectangle. So I know that it's 4/10 wide and 1 long. So 1 times 4/10, or just one group of 4/10, makes 4/10. Next, I'll go on to this rectangle here, which is, according to that number, 2 long, right here. So that distance is 2. And we're going to multiply it by 3/10. Now it's helpful to think about Elena's or Noah's strategy. Remember that Elena likes to convert decimals into whole numbers. So she would pretend that this was 2 times 3 instead of 3/10, but then she needs to take a tenth of her answer. So if we do 2 times 3/10, we get 6/10, which gives us that decimal there. The last one is this one here, which is 3/10 tall and 4/10 wide. I'm going to use Elena's strategy. Instead of doing 3/10 times 4/10, I'm going to do 3 times 4. I count 2 decimal places that are fractional in my problem, so I'm going to need 2 in my answer as well. So I'm going to go ahead with 3 times 4 makes 12, but I need 2 decimal places there. So this one here is 12/100ths. I can also show fractionally why that works. If I do 3/10, which I'll check with Noah's strategy, times 4/10, 3 times 4 makes 12, 10 times 10 makes 100. So 12/100ths looks like that. So these are the areas of each of the regions. How we answered this question, 2 and 4/10 times 1 and 3/10, would be to add each of these pieces together. So use what you know about adding decimals to carefully add each of these once you've lined up the decimal place, and check your work with a calculator.